I'm Anil Kumar, and now let us solve quadratic inequalities graphically. We have 4 examples on this sheet. I will do 2 of them, and the other 2 are for you to practice. The first one is x times x plus 3 greater than 0. The second one is x minus 2 times x plus 3 less than 0. And then we have x plus 3 times x minus 4 greater than 0 and 2x times x minus 5 less than 0. Now we'll use graphical method to find the solution of these inequalities. Now first thing is, from here this is in factored form, so we can straight away write down what our zeros are. So the zeros are at x equals to 0 and at x equals to minus 3. The second thing what we notice is that the leading coefficient is positive, so we have a parabola, right, that opens upwards. Now with that information we can actually sketch the parabola. So let's say this is x-axis, right, and we'll just sketch a parabola opening upwards with 2 zeros, right? So we'll say, well, this is our parabola opening upwards with 2 zeros. Where are the zeros? Zeros are at minus 3 and 0, right? Minus 3 will be on left side, and since we are looking for greater than 0, minus 3 should be not a part of solution, right? So I'll just draw kind of a hole there. Minus 3 and 0, right? So the points are minus 3 and 0. We are looking for a solution where the function, the quadratic function, is x times x plus 3 greater than 0. So we see this part is positive, right? So this part is positive, so that's part of solution. And here also from minus infinity to minus 3, we have positive. In between is negative, so that is not a part of solution. Now we get our solution. Now I can write down this answer in different ways. So I'll write them in set builder form and on a number line. So these are 2 standard ways in which they are normally written. So I'll use these ways in most of my videos. Now on a set form, we say it's x belongs to a set, means these curly brackets. We say x belongs to set of all the real numbers, and the condition is that it is actually less than minus 3. So we say x is less than minus 3, union. So there are 2 parts to this solution. Union is, and x is greater than 0, right? So x is greater than 0. So that forms this portion which we have shown here when the inequality greater than 0 is true. If I have to show this solution on a number line, then we'll draw a number line like this which moves on both the sides. And then we have 2 zeros which I'm drawing like a hole because these points are not included. Is greater than, right, not including 0, and the solution is towards infinity from these holes, right, and towards minus infinity, and these 2 points are minus 3 and 0 for us. So on a number line it can be shown like this, right? So that is the method which we are going to use in a couple of videos, at least 4 of them, where we'll show you how to solve quadratic inequalities graphically. So we'll take different kinds of quadratic functions. This one is a set of factored equations for you, right? So that you don't have to really do factoring. In the next set, you may have to do factoring, okay? Now the second one, we'll follow the same process. First, write down what the zeros are. You know how to find zeros, right? X minus 2 should be equal to 0. Let me write down this time. And that means x is equals to 2. So that is the first 0. The second one is x plus 3 equals to 0. That means x should be equals to minus 3. So that gives me 2 zeros for this quadratic function. So we know the zeros now. Let's say this is our x-axis, right? Now, will the graph open up or down? If I multiply x and x, I get x squared, which is positive. So the parabola opens up, right? So that is one thing. So let me just sketch a parabola. We are not very particular about the y values in this case. In inequalities, we know that zeros actually divide the whole coordinate plane into, if there are 2 zeros, 3 parts, right? So that is how it is. Let me just draw first and then explain you. As you can see here, there are 3 parts in which the plane has been divided. So one of the part is from minus infinity first 0, the second is between the 2 zeros, and the third one is from the second 0 to infinity. What we try to do is test in which part is the inequality true. Here we are looking for less than 0. So where is it less than 0? We find in between zeros it is less than 0. So that is the part of solution. Do you understand? So that is how we solve the inequalities graphically. Right? So we had zeros at -3, negative value, which is lower comes first. Well, and 2, which is higher than this, comes on the right side. Now we know that this part of our graph is the solution to the inequality. Let's write down the solution in formats which should be good enough, right? So one of them is the set builder form. So in this, we say this is the set of numbers where x belongs to real numbers. And what is the condition? The condition is that x is greater than -3 and less than 2. Right? So that is a way in which we can write down our solution. Second is that we can also show it on a number line, right? So on a number line, let's say this is our number line. We know that's between -3 and 2, but not including -3 and 2. So these are the two holes which are at -3 and 2, right? And then everything in between is part of solution. So we say it's from -3 to 2, everything in between, not including the holes which are at -3 and 2. I hope that makes absolutely clear how to solve quadratic inequalities using graph. Now try it out with part C and D. C is x plus 3 times x minus 4 greater than 0. And then we have 2x times x minus 5 greater than less than 0. Now, so in this case we have two zeros in each, right? The zeros are at -3 and +4. Zeros are at 0 and 5. Sketch your graph, write down your solution, and then move on to the next video. I hope you understand and appreciate it. Thank you.